All right, let's get started on our Chapter 5, 1 through 5, 4 review for pre-calculus. This goes over composition of functions, inverses, exponential functions, and logarithms. So step one. So looks like a lot of problems to begin with, but we'll take it piece by piece. Find f of g of 4. So step one, plug 4 into g. So that is f of 1 minus 3 times 4 squared. So that's f of 4 squared 16 times 3 is 48. So 1 minus 48 is negative 47. F of negative 47 is 2 times negative 47 squared. So that's fun. So what do we get here? It's going to be a positive 47 times 47. This would be helpful if you had a calculator. We'll see this up here. So that is 2 times 2,209. So this is when a calculator comes in handy. 2 times 2,209 is 4,418. Next up, find g of f of x. I want g of 2x squared. So wherever I see an x, I'm going to write 2x squared in g. So that's 1 minus 3 times 2x squared squared. Well, 2 squared is 4. X squared squared is x to the 4. So that's 1 minus 3 times 4x to the 4th. So last but not least, it's 1 minus 3 times 4 is 12, x to the 4th. There we go, composition of functions. Find g of 0. Well, what's g of 0? G of 0 is 1 minus 3 times 0 squared, so that's 1. So really, I'm asking what's g? So that's g of 0. It's the same as g of 1. G of 1 is 1 minus 3, 1 squared. So that is negative 2. Find the domain of f of g of x. So we say, what is the domain of g? Well, looking at our function, it's all reals. What's the domain of f? Same, all reals. So what's the domain of f of g of x? All reals. Moving on. If we have f and g for number 5, find the domain of g of f of x. I want to know what g of f of x is. So I want to know what the domain of f is, and I want to know what the domain of g is. So the domain of f, we look at f, x cannot equal negative 3. We look at g, x cannot be 1. If I want g of f of x and I want the domain, my domain consists of what f can't be, x can't equal negative 3. Then we set f equal to what g can't be. We don't want f to be 1 because if f is 1 and we plug that in and get 1 out, this comes out to be undefined. So we set f equal to 1. So we say 1 equals 1 over x plus 3. So x plus 3 equals 1 if we cross multiply. So subtract 3, x equals negative 2. That's what we don't want it to be. So x cannot be -2. There's my domain. Same question. Find the domain of f of g of x given these two functions. So what's the domain of f? Well, we look at f. X has to be greater than -3 because it's the square root function. We look at g. What's the domain of g? What makes this 0? So we say 3x minus 1 cannot be 0. So add 1, divide by 3. X cannot be 1/3. So if we're saying what's f of g of x, what's the domain? Whatever g can't be plus whatever f can't be. So here, the domain here is g can't be 1/3. If I plug g in under the square root, I still have some number plus 3. So we take -3 plus 1/3. We want numbers that are, if we did it, let's just plug it in. -2 over 3x minus 1 plus 3. That's our composition of functions. If we look at the domain here, we want to know, well, x can't be 1/3, and what makes this -3? So we say -2 over 3x minus 1 is greater than -3. So -2 is greater than 9x plus 3. So 1 is greater than -9x. So that means x is greater than -1/9. So x can't be 1/3, and x is greater than -1/9. Hopefully you were able to follow that logic, but what did we do? We found what the domain of g of x was. That's what it couldn't be. Then we set g of x equal to the parameters for the domain for f. Moving on. So the next part we talked about is a function 1-to-1. This is if we're looking at all of our x's. Every x goes to exactly 1y. So here we have b, d, j, and c. B goes to k, d goes to d, j goes to p, c goes to p. The question is, does every x go to exactly 1y? B goes to k, that works. D goes to d, j goes to p, c goes to p. Because these both go to the same, this is not 1-to-1. If we're given a graph and we want to tell if something's 1-to-1, we look if it passes the horizontal line test. This fails, so this is not 1-to-1. We look at our next function and we look all the way across. This is not 1-to-1 because it fails the horizontal line test. If we want to graph the inverse, it's going to be the reflection for number 9. It's going to be the reflection over the line y equals x. So this ordered pair right here is -3, -2. This one right here is -2, 0. This one right here is -1, 1. And here it's 0, 3. To graph this inverse, we switch the x's and the y's. So let's do that in a different color. So instead of at -3, -2, we're going to be at -2, -3. Instead of at -2, 0, I'm going to be at 0, -2. Instead of -1, 1, I'm going to be at, switch them, x is 1, y is -1. And instead of at 0, 3, I'm going to be at 3, 0. So now if I connect these dots, and I look at these two, these are mirror images of each other across the line y equals x. So how do we make that point more clear? Inverses are symmetrical with respect to the line y equals x. How do you find the inverse for a function? Step 1, write y equals negative 4x. Step 2, switch the y's and the x's. So x equals negative 4y. Step 3, solve for y. So here, simple case, we divide by negative 4. So I have y equals negative 1/4 x. That's the inverse. Done. Moving on. So we're continuing finding the inverse of a function. So we're going to look at we're going to start with number 12. Find the inverse. So step 1, write y equals instead of f of x. Step 2, switch the y's and the x's. So x equals 4 over y plus 2. Now solve for y. So cross multiply. We have x, y plus 2x equals 4. Subtract 2x. So I have x, y equals 4 minus 2x. Now divide both sides by x. I get y equals 4 minus 2x all over x. Try it again. Find the inverse of g of x. So step 1, write y equals 2x over 3x minus 1. Step 2, switch the x's and the y's. So I have x equals 2y over 3y minus 1. Step 3, cross multiply. So I have 3xy minus x equals 2y. Get all of the y's on the same side, get everything else on the other. So I'm going to subtract 2y and I'm going to add x. So I have 3xy minus 2y equals x. What's common between these two terms? A y. Y equals 3x minus 2 equals x. Last step, divide by 3x minus 2. So I'm left with y equals x over 3x minus 2. There's my inverse. So let's complete this chart. What's the domain for 14? The domain here is what x can't be. So x cannot be 1/3. If I look at the domain for my inverse, the domain of the inverse will be x cannot be 2/3. I set the denominator equal to 0. Well, here's where it gets easy. The domain of the inverse is the domain of the function is the range of the inverse. So the range is x cannot be 1/3. The domain of the inverse is the range of the function. So the range here is x cannot be 2/3. You get those for free without knowing how to find horizontal asymptotes. Next up, graphing exponential functions. How can we graph a function like this? Y equals 3x minus 1. Well, this minus 1 here gives us this moves it down 1. So how we describe graphing these every time we write our x, we have our y. We write -1, 0, 1. We pretend like that number doesn't exist. So we say, what's 3 to the negative first? 1/3. What's 3 to the 0th? 1. What's 3 to the first? 3. Now that -1 is on the outside, so we subtract 1 from each of the y values. So if I graph that, at -1, it's going to be at negative 2/3. So at negative 1, negative 2/3. When it's 0, x is 0. When x is 1, y is 2. I have a horizontal asymptote at y equals negative 1. Let's make sure that connects. So there's my graph. That's 3x minus 1. Next up, graph y equals 4 to the x plus 2. This x plus 2 moves it left 2. It's inside my function, so it's affecting my x. So if I make my table, x, y, negative 1, 0, 1, this should be 1/4, 1, and 4. Now I'm moving left 2, so that's a negative 2, that's a negative 2, that's a negative 2 to each one. So I draw my table at negative 1 minus 2, that's negative 3, 3, it's 1/4. At 0 minus 2, so at negative 2, x is 1. At negative 2 plus 1, that's negative 1. My y is 4. 2, 3, 4. So it shifted my graph 2 to the left. I still have a horizontal asymptote at y equals 0, and I'm good from there. 17. I'm going to rewrite this as y equals 1 minus 2 to the negative x plus 3. Either way you do it, we'll get an answer out. So let's look at just the original. Y minus 1/2 to the x plus 3. So if I write negative 1, 0, and 1 in there, I have x plus 3, so that's shifting everything to the left, negative 3, negative 3, negative 3. That minus in front, that should be x 1/2. 1/2 to the negative first power is 2, 1, 1/2. That negative makes each one of these negative. That 1 in front, add 1, add 1, add 1 to the y's. So if I redid this table, x, y, 1 minus 3 is negative 2, 0 minus 3 is negative 3, that's negative 4, negative 3, that's negative 2. Here I have negative 2 plus 1, so that is negative 1. I have negative 1 plus 1, which is 0, and I have negative 1/2 plus 1, which is 1/2. So this graph is up 1, flipped, and left 3. 1, 2, 3, 4. Let's put my values on the chart. So when x is negative 4, y is negative 1. When x is negative 3, y is 0. When x is negative 2, y is 1/2. We have a horizontal asymptote at y equals 1. And our graph goes like that. There's exponential functions. We are almost done. We're going to the last page. So the last bits that you guys need to know about is the information that we covered most recently. So that's logarithms. So finding the domain of a logarithm, we take what's on the inside and set it greater than 0. So here we have 3x minus 4 is greater than 0. So that's my domain. So if I solve this, I add 4, divide by 3. I have x is greater than 4/3. That's my domain. That also gives me my vertical asymptote. My vertical asymptote is x equals 4/3, even though I didn't ask that from you. 19. Kind of looks scary. This number out front is a shift up 2. That 1/2 is a vertical squish. This number on the inside affects my domain. So I take what's on the inside. Say 4x plus 6 is greater than 0. Now I solve. Subtract 6 4x is greater than negative 6. Divide by 4 and simplify. X is greater than negative 3 halves. That's my domain. That also gives me my vertical asymptote at x equals negative 3 halves. So next up, graphing. How can we do these problems? Looking at 20, graph the log base 5 of x plus 1. So I'm going to first make a table, x, y. I'm going to write negative 1, 0, 1 on my y side. What's my base? 5. So what's 5 to the negative first? 1/5. What's 5 to the 0th power? 1. What's 5 to the first power? 5. That negative 1 shifts my graph to the left 1. So I'm going to subtract 1 from each value in my x. How does that also affect my domain? My domain, x is going to be greater than negative 1. I'm going to have a vertical asymptote at x equals negative 1. So let's put all of that information in there. At negative 1, I have a vertical asymptote. When y is negative 1, x is 1/5 minus 1. So that's negative 4/5, which is almost 1. So let's put my point right there. When y is 0, x is 0. When y is 1, x is 5 minus 1, so that's 4. 1, 2, 3, 4. There's my point. There's the graph of log. Find the inverse and graph it on number 27, which really should say number 20. So what's the inverse of this function? Well, you have to remember your bay. So the base is 5 to some exponent equals x plus 1. 5 to the something equals x plus 1. Let's say that's y. 5 to the y equals x plus 1. So really, what we're graphing is 5 to the some power minus 1. So if we graph this, we make our table. Let's see what happens. X, y, the inverse should be pretty easy because we should have negative 1, 0, 1. And then if we look all the way over here at our other table, that's 1/5 minus 1, so that should be negative 4/5. At 0, this should be 0. And at 1, it should be 4. So if we'll have a horizontal asymptote at negative 1. When x is 1, we get negative 4/5. When x is 0, y is 1. When x is 1, y is 4. So if we graph those 3 points, and what we wanted to point out is these two things are symmetrical about the line y equals x, because these two are inverses of each other. So last bit, graph these functions. Graph 22. 4 plus log 1/2 of x minus 1. So I have, making my table, x, y, I have negative 1, 0, 1. My base is 1/2, so I have 1/2 to the negative first power is 2, 1/2 to the 0th power is 1, 1/2 to the first power is 1/2. That minus 1 adds 1 to my x's. That 4 on the outside adds 4 to my y's. So now that I take my points, I will have a vertical asymptote at x equals 4. Sorry, x equals 1. So when y is negative 1 plus 4, so when y is 3, 2, 3, x is 2 plus 1. So when y is 3, x is 3. When x is 2, y is 4. So when x is 2, y is 4. When x is 1.5, y is 5. 1.5, 5. So what's happening here now, before we do this, we should have y, find the inverse and graph it on number 29. So we have y minus 4 equals log of 1/2 x minus 1. So if we switch these, we say 1/2 to the exponent, 1/2 to the x minus 4 equals, switch the x's and the y's, y minus 1. We have 1/2 x to the negative 4, x minus 4 plus 1 equals y. That's my inverse equation. And we already know from the previous graph what the table should be. So we just switch the numbers. So negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. My y values, 2 plus 1 is 3. 1 plus 1 is 2. 1/2 plus 1 is 1.5. I'm going to have a horizontal asymptote at y equals 1. And this is going to shift it to the right 4. So let's see. If I put all that together, I'm going to have my horizontal asymptote at 1. When x is, 3, y is 3. When x is 3, 2, 3, y is 2, 3. When x is 4, y is 2. When x is 5, y is 1.5. And let's see what we're graphing right here. So there we go. There's the inverse for these two functions. Hopefully this was helpful. We'll be going through this in class, and your test will be a lot shorter than this review. All right, good luck.